How can a simple line on a graph tell the whole story of a journey? In this video, we're going to break down distance-time graphs so you can read them like a map of motion. You'll see how to spot when something's moving quickly, slowing down, or standing still, and how to calculate speed directly from gradients and tangents. By the end, you'll be able to turn any distance-time graph into a clear description of what's happening and ace those exam questions with confidence. Let's get started. Okay, so here's a good example of a distance-time graph. Now, when we're trying to analyse these graphs, we might have to do it with calculations, but first we have to be able to do it with words. So we need to be able to describe what each step of our journey is showing us. Now, we're kind of looking for two things. The first one is, are the lines straight or are they curved? Now, if we've got straight lines, that means speed is staying the same. If we've got curves, that means speed is changing. The second thing that we look for is we're looking at the gradient. How steep is that line? Because the steeper the line, the bigger the gradient, the faster that object is moving at that point. So if we have a look at our sections of the graph, we've got section A and section B. Now they both look quite similar, straight lines, but I hope you can see that B has got a shallower gradient. Now what this will mean is that at B, our object is traveling slower than if it's at A. Let's move on to section C. Now again, we've got a straight line. This is showing us that speed isn't changing, but this is a rather special example for a distance time graph. What this is showing us is that our speed isn't changing, but importantly, this speed is zero. Have a look. Time is elapsing, but they're not going anywhere. The distance isn't changing. So this would be something that is stationary. Now the final part of this graph, we've got a curve. Now what this curve is showing us, as we said, is that a curve means that speed is changing. Now have a look at the gradient of this curve. Can you see that the gradient at the beginning of the curve is less than at the end? So it's steeper at the top here. This is a gradient that's increasing. Now if the gradient is increasing, that means that the speed of this object is increasing as well. So what we've got here, we've got a journey where to begin with our object is travelling at a constant speed. It then carries on travelling at a constant speed, but slower than in A, then stops for a little period of time, and then what we can see now is that the speed is increasing. And we often might say in GCSE or A-Level that our object is accelerating. So now that we've had a look at describing it with words, we're going to move on now to having a look at trying to do some calculations with our graphing as well. Right, so let's have a look at trying to work through these examples. So we've got three sections here. We've got A, B and C. What I'm going to do, I'm going to show you how to do A and B, and then it'll be an opportunity for you to try C on your own, and then we'll go through that together. So the key, whenever you're doing gradients, is always to draw a nice big triangle. Now, the way that this graph is, it's such that we can draw a really big triangle here, the length of the entire line. So let's draw a nice big triangle on here, a little bit like this. And what I always think is quite a helpful thing to do is to actually just read off the values for your Y and for your X. And you'll find that actually then it just becomes a little bit easier when you're trying to work out your gradients. So let's have a look at the y-axis first. So we can see this point here is at 20, this point here is at 0. So my change in y is going to be 20 minus 0, which equals 20. And that's of course in meters. Let's have a look at our x-axis. Again, I always think it's helpful to put the values on here. So we've got 8 here, 0. So our change in our x-axis is 8 minus 0. Which is 8 seconds. So what we can now do for region A is that we can work out the gradient. So there are loads of different ways you might have seen this. It might be rise over run, it might be changing up over changing across. I'm going to use delta y over delta x. So we've just worked out that our change in y is 20 meters, our change in x is 8. So let's come across the calculator. 20 divided by 8 gives us 2.5. So that's going to be 2.5 meters per second. So that's our first section done. Let's have a look at our section B. So for section B, again, what we're going to start off with drawing that nice big gradient triangle. Now this one of course isn't actually stuck on the y-axis or the x-axis like this one was, so we've got to be a little bit more careful here. So good thing to do, again, let's get the ruler on here. I know that I'm drawing up to this point on the line here, so let's just work out where we've got to start. So here is the base of our gradient triangle. That means we can draw the height of it nice and easily. So once again, I'm going to do it in a different colour so it stands out. Let's have a look at measuring off our x and y values. So again, let's start with the y-axis. So this here is 80. This here is 20. So my change in y is going to be 80 minus 20, which is equal to 60. And then let's have a look at our x-axis. So this here is 8. This here is 14. So my change in x will be 14 minus 8, which gives us 6. Now from here I can work out my gradient of section B, and this is going to be again delta y over delta x, so this will equal 60 divided by 6. I hope we don't need a calculator for this one. This is going to give us 10 meters per second. Now I always think it's a good idea to check your answer, make sure it seems sensible. Now we can see just by eye that B is a steeper gradient, so we were expecting it to be a higher speed, and if we compare our speed for A to B, we can see that that is the case. B is much faster. So now's the time, pause the video, have a go at section C for yourself, and we'll come back in a second and see how that went. So let's have a look at section C. I hope it went well for you. So once again, let's draw this triangle on. I know it's going to be from here. We'll go green this time, I think. So there's a nice big gradient triangle on. If you're doing this in exams, if your gradient triangle is too small, you can actually lose a mark sometimes. So this is very important. Right, so let's have a look at our change in y. So this is going to be 100 minus 80. So that's a change in y of 20. And then looking at our x-axis, 20 here and 14 here, so this is going to be 20 minus 14, which equals 6. So that means my gradient of C is going to be 20 divided by 6. Let's bring the calculator back in. 20 divided by 6 gives us 3.3 recurring. We'll round that to 2 sig fig, I think, in this case. So that gives us 3.3 meters per second. Once again, it's a good idea to have a little check of what we've done. So if we have a look at region C, we know it's got a smaller gradient than B, so it should be less than 10, but just by eye it looks like it's steeper than A, so that value there of 3.3 meters per second should be the right answer. It's always nice to have a little bit of confidence in that final moment when you've got that calculation out, so it's always worth just trying to see if you've got something, either a value you know or something you can compare to, and that will give you a bit of confidence having finished that question. So we're now going to move on to curves, because these are a little bit different. We've got a step that we need to introduce before we start doing anything with gradients. So let's have a look at some curves. And the process for dealing with curves is going to be a little bit different. Obviously, we can't just use a gradient because it's not a straight line. So we're going to have a look at a process where we're going to draw a tangent at a particular point in time and then work out its gradient. Now, this is definitely a high level skill. At GCSE, this is definitely grade 7, 8 or 9. But you are expected to be able to do this at A level. So it's one of these things, as always, just practice it a bit, have a go at the ones that I show you again if you need to, and I'm sure you will get there in the end. So once again, we'll go back to the visualizer and I'll show you how to work out the gradient of a tangent. Let's have a look at this process of tangents and gradients. It doesn't really matter what time we choose here. I'm going to choose 3 seconds. So we're going to have a go at trying to estimate the speed of our object at 3 seconds. So the first thing I'm going to do, you can see, I've just marked on the curve where 3 seconds is. And then our first job is we're going to have a go at trying to draw a tangent. Now the key with the tangent is we're trying to get our ruler to be as close to the slope of this curve at 3 seconds as we can possibly make it. So what this means is I'm just going to have a little play around this, and this is why they're estimations. They're never going to be perfect. What we're trying to do is just do this the best that we can, and it's always a bit of trial and error, but I think it looks about there. So my first job, I'm just going to draw this nice and long. And so there is our tangent at 3 seconds. Now from here, what we're going to have to try and do is to try and again draw on a nice big gradient triangle. And I always think it's helpful that when you're looking at your line, try and just see if that line passes through any kind of helpful points to make the measurements a bit easier. So can you see passes through this point here? So what that means, I'm going to use that as one of the points for my gradient triangle. And if we come down, looks like it passes through another point here that's quite handy. So from this, I'm going to draw my gradient triangle. So let's extend this out a little bit. Let's draw this down. And there's my triangle here. So we're going to use this now to work out the gradient of that tangent. So once again, just like we did before, I'm going to measure off the values that we've got here. So this is 70, this is 25. So my change in y is going to be 70 minus 25, which is 45 meters. And then let's have a look here. Have a look at our x-axis. So this here is 6 seconds. And so each of these little squares are 0.2. So that there is 0.4. So my change in x is going to be 6 minus 0.4, which gives me 5.6 seconds. So once again, if I want to work out the gradient, it's going to be my change in y over change in x. This would be 45 divided by 5.6. Let's move over to the calculator. And that gives me, again, we'll do this to two significant figures. This gives me 8.0 meters per second. So now it's your turn. What I'd like you guys to have a go at is to try and see if you can work out what the speed of this object is at 12 seconds. So what I'd recommend, pause the video there, try and see if you can work through, use the method that I've just shown you already, and we'll come back in a second and see how that went. Okay, so let's have a little look and see how that went. Now remember, when we're doing this, the values we're getting are estimations. Because we're drawing tangents on here, they're never going to be exactly the same every single time. So the idea is that we're looking for an estimation. So I got 8.0 meters per second on my last version. You may have got something similar. Again, I'm going to work through this one here. Hopefully you'll get something similar to mine and you've used a similar method. So just like before, we're going to draw the tangent on, make it nice and long. And all that I'm trying to do here is to try and find some nice points through which this line is going to pass. So where shall I go? I'm going to choose there, and then let's try and find one. Yeah, now look at that. That's perfect. That's nice and easy there. So let's draw this triangle in. So it looks a little bit like that. Right, so let's do the same as before. So we'll just measure on these points on here. So that's 65. So my delta y will be 100 minus 65. Delta x, so this here is 18, and this here is 4.6. So my delta x will be 18 minus 4.6. That gives me 13.4. Oh, I didn't work that one out. Look, there we go. That's 35. So final thing to do, we need to work out our gradient. So that's delta y, delta x. That's 35. Divided by 13.4. Let's get the calculator out. And so it gives me 2.6 to two significant figures. Now again, just in terms of comparing that answer, when we had a look at 3 seconds, obviously it's much steeper here. So we've got a larger velocity. We had a speed that was 8 meters per second here. We've now got a smaller speed. So this time we've got 2.6 meters per second. That seems about right, so I'd feel quite confident. Okay, so we've covered quite a lot in our session today. So obviously we started off by looking at describing distance-time graph with words. We then moved on to doing some calculations with straight line sections of graph using gradients. And then of course we moved on to then looking at curves, drawing some tangents on, and then from those tangents working out gradients. Now like we say, these are ever increasingly demanding skills, and they're ones that come with practice. And the best thing you can do, pause the videos, go back, revisit some of the other bits and pieces, and just have another go at them. And you'll find that over time, you'll feel an awful lot more confident with this. Anyway, I hope that helped today. As always, please like and subscribe. And in the comments section, if there's anything you'd like me to do in another masterclass, please suggest it. See you soon.